Welcome back to Hoochos. Today on Hoochos, I'm going to take you for a walk around the garden again, and we're going to actually have a look at the hydroponic potatoes because a heap of you are interested in those. I'm also going to take you over to my current shed where I show you a new 3D printing design that I've made, and I'll give you some tips on printing the Hooch bucket design. So first things first, the potato system. Now this is the potato system. I haven't given you much info on it because I'm going to show you how to make it in a future video. But basically you can tell it's a rain gutter grow system. And in here, well, it looks a lot like the chicken fodder system, and that's because it's adapted from that system. I'm going to give you a look at the potatoes that are in the system. I'm showing you because I looked the other day and it was super exciting. So we'll just pull back. This is sugarcane mulch, and there's a potato there. And I've got them spaced fairly evenly throughout the bed. The reason the sugarcane mulch is there is so that, where's the other potato? There it is. Is so that the potatoes have, I think they're called chemoreceptors, essentially mechanical receptors on them that allow them to feel that they're surrounded by a substrate, and this then allows them to essentially bulb out. If you don't have a substrate around them, they won't make more potatoes in the traditional sense, like they'll turn weird. So that's what the mulch is for, so that when they grow up, they push out more tubers. Essentially, what I'm trying to achieve here is to get the potatoes to root into this cocoa core substrate. So we'll pull out one of these potatoes and I'll show you how the progress is going. So if we just gently lift that, you can see the potato is rooting, and also you can see that it's actually sending out a shoot, and that'll become the stem and the leaf. And that is a hydroponic potato. So we'll just chuck that back in the ground. And we'll have a look. Why not? Now I'm probably gonna disturb these potatoes a little bit, but that's okay. This is for the good of science. So I'm just gonna lift him up. Oh, this one's really rooted in. Actually, you can see the roots on the side there. Oh, those roots are a lot further along than I thought. Look at that. These have been in here for about a week now. So you can see the progress that potato's made. So that's coming along rather nicely, and you can see there's a shoot there, and that will become the stem and the leaves. So put him back in the soil. It's nice, you can tell it's really moist with hydroponic nutrient, and it's wicking nicely. We'll put him back. There we go. I'll just cover him up. There we go. That's a sneak peek at the potato system. All right, let's move over to the greenhouse. Here we have the greenhouse tomatoes, which, as you can see, I've trimmed right back. I had a problem with these the other day. In fact, not all of them, just the one bucket. And you can see here, there's algae growing around the top of this bucket. And I noticed that and I was like, why? And why is there perlite essentially walked up the side of the bucket? And the reason is that this plug hole here blocked up because the hole behind the thread essentially wasn't large enough when it had been poked to make the original liquid come out of this container. It wasn't opened completely, and the little flap of plastic that was behind it had closed back over from the water and the perlite and the media within the system, and caused this to essentially fill up with irrigation cycles. Now, luckily for me, the irrigation cycle only filled it to about here, and then the cycle stopped for enough time for it to slowly drain back out through this hole. So what I did was I undid this screw and I drilled it out and got that water draining away nicely. Now, as you can see, this plant has actually been affected by that pooling of water. You can see in the leaves, this is the only plant that I have that has some sign of plant stress on the leaves, and you can see it here, and I'm fairly certain that that is directly caused by that bucket staying full of nutrient. As you can see on all of the other plants, the leaves are actually perfect. So only that plant, which has had this drainage problem, has this sign of stress on the leaves. It's really interesting to see what a lack of drainage can do to a plant. But that should clear up now that I've fixed the problem. As you can see, the fruits weren't negatively affected, just the leaves. So I'm pretty happy with how that turned out. The tomatoes are fruiting like mad. These are really nice, large beefsteak tomatoes. And I don't want to say it too loud in front of the plants, but I'm really excited to eat them. All right, so this is the NFT lettuce. Now, I've got a mate who's been properly educated in agricultural sciences, and he looked at them and immediately said, "Hooch, you've got too much nitrogen." And I tend to agree. He reckons there's too much leaf. Essentially, the reason the plants aren't heading up and are focusing on huge leaf growth is because there's too much nitrogen in the nutrients, and the cells are bulking up with water, which makes them less nutritionally dense. And it also means that the heads aren't heading up in a nice consolidated way that he would, as a grower, take to market. So I've got to look at that nutrient ratio, which was 1 gram per liter of the nutrient mix and 1.5 grams per liter of the calcium nitrate. So I'll probably be tweaking that. I'll either take it right back to 1 gram per liter for each, or 1 gram per liter for the other elements, and then 1.25 grams per liter for the calcium nitrate. I'm just going to tweak with that recipe a little bit because I do think that the nitrogen content is a little high. And from my mate's advice, I just want to see if I can get these lettuce to head up a little bit more so that they're not so watery, I guess. So with this channel, I'm actually trying to actively clear it out. I want to put in hydroponic strawberries. So as far as I was aware, I thought that strawberries preferred not to have wet feet. So having strawberries in an NFT didn't really make sense to me. However, this same mate who told me about the over nitrogenation of the lettuce actually showed me pictures of his NFT system, which has strawberries in it, which is going absolutely nuts. So now it shouldn't be a surprise to me that NFT's surprising me again. So what I'm going to do is I'm going to plant out this NFT with strawberries, and I'm not sure how I'm going to hold them in system yet. I think I'm going to go with pucks, purely for the fact that they are already rootstock, and that will make it a lot easier for me to just plop them in the system rather than trying to feed them through net cups. I might even come up with a new 3D print design. I'm just trying to work my head around how to use TPU, which is a rubberized plastic. I'm thinking maybe like a plug shape with a rim around it, so you can just slot it into the hole, and then a slice down the middle and a cross in the slice, so that you can then just insert your plant. I'm just working with the density in my head. I'm thinking maybe like a 10% infill so that it has that flexibility but also holds the plant upright. I'll let you know how that thought process goes. TPU is a little bit more expensive than other print filaments. Let me work on it and I'll get back to you about that. Here we have the dog bowl auto refill system. Now I did have 3 plants in here. 2 of them succumbed to some kind of aphid. I'm not sure what it was, but I had to rush them out of the greenhouse so that it didn't affect
all the other plants that I've got in here. But essentially, yeah, I had 3, now have 1 plant, and it's going good. I've just been using a Q-tip to pollinate it. Same with the tomatoes. I have heard that if you've got wind within your greenhouse, you do not need to pollinate your tomatoes. However, I was having a really low pollination rate on some of the ones in this level of the tomatoes. And you can see like those were pollinated before I had this shade cloth on. And these ones were pollinated after I had the shade cloth on. And you can see that there's a lot less success in this level. So what I've done is at this level I started pollinating, and so about here we should start seeing more tomatoes coming through, or a greater density of tomatoes coming through, purely for the fact that I really didn't know how much work those pollinators do. They are the best. So like, save your bees, I guess. Come down to here, we've got the Hooch buckets, playing with more designs. These are 2 different lots of rootstock of strawberries that I got. These were Bunnings buys. You can see the leaves, they were a lot further along than the other ones I purchased, but they were also a lot more expensive. Here you can see the rootstock that I got delivered in the mail, and that is exciting. That means it's alive, and I was worried there for a little bit. These ones are definitely alive, but they came in the packet pretty much looking like this. I wasn't too worried about those straws. And over here, just in some pots with cocoa and perlite, I've got some more strawberries, and they're just all surrounding the outsides. What I'm trying to get them to do is I'm trying to get them to put out these green leaves so that I can then transplant them into the NFT. I want them to root out so that I can have the most roots in solution that I can get. There should be about 20 or 30 plants in both of these buckets. Some of them are in the middle. I know I shouldn't be burying the crowns, but I just wanted to make sure that I got all of these to root. And then I'll transplant them into the NFT. The Hooch bucket capsicums are doing really well. So you can see here, they're flowering, and I've been pollinating these with the Q-tip as well. You really do take those pollinators for granted. I've actually been cross-pollinating these guys with the jalapenos that are in the rain gutter grow system. And let me just pull out a bucket so that you can see. There you go. That's a root coming out from the bottom of the Hooch bucket. And in the other ones, there is some more. There you go. So the roots are going down into that nutrient solution and making it fully available to the plant. Now I recommend not doing that, not taking them out, because when you drag the edge of the net cup against this, you could slice off some roots. Now you can actually make those holes bigger. It really doesn't matter what size those holes are underneath this pot, because it is keeping that light out of solution. So make those holes as big as you like, and that'll allow you to pull these buckets in and out. The major difference between the design of these buckets and the net cups is that the sides of that are straight up and down, rather than tapered in like a net cup. And if the roots are coming out the sides and you're dragging that pot up and down on the edge of that hole, there is the possibility that you're going to slice off some of those roots. So just be mindful of that when you're handling the pots. This may be something I take into consideration in further iterations of this Hooch bucket, but it's still working for the time being. Just something to be mindful of. The less disturbance, the better, really. All right, so there's a lot going on here, and the bench is a bit of a mess, but the point of these videos isn't to present a polished view of my world. It's just to show you what I'm doing. So I have been working
a lot on the 3D printing of these buckets and this, which is the new design. And this is the first one to print correctly, so I'm really excited to show you that. I'm going to pull it off that bed right now. I just want to show you, like, not all these things go to plan. This is one of the failed prints. I mean, look at that adhesion, really nice, but it failed somewhere along the line, and there's a lot of failing happening in and around this space. So don't feel like if you're having trouble with 3D printing that you're the only one. I'm just going to quickly throw a lapel on because I'm not sure how the printer sound is affecting my voice. Alright, so these printers are actually located in my shed, which is far from environmentally sealed, and I've been having a lot of problems with the PETG, the filament, actually absorbing water. Now, these videos are actually going to be available on my Patreon. I'm going to start doing specific 3D printing exclusive videos purely about the Hooch pots, because I know that a lot of you aren't interested, are mostly interested in the hydroponics content and aren't 3D printer oriented. So I'm not going to throw up a ton of troubleshooting videos specifically for Hooch pots and stuff on my main channel. I'm just going to do Patreon exclusives because the Patreons are the ones with the Hooch buckets, which kind of makes sense. Similar to this, where I'm explaining how to troubleshoot things in the process of making the Hooch buckets and all of the accessories that I put onto my Patreon. So you're not missing out on anything if you haven't printed a Hooch bucket or any of the stuff that I'm putting on the Patreon. I'm just letting you know that there is content on that Patreon, or there will be content on my Patreon which will further explain how to get a better result with these systems. So at the moment I've been having problems, I'm pretty sure, with the PETG gaining moisture content whilst it's sitting on my rolls, and it's causing some prints to fail. Some people have pointed out that the stringing that I'm getting on some of my prints is due to my retraction settings, but I'm not sure how to fix that. If any of you guys know how to fix that stringing, I'd be very interested. Now, this is a new design that I'm working on currently, and I'm pretty close to releasing it. I just need to make sure it works for myself, and then I'll release it to the Patreon community, and I'll do a specific video about this design as well. This is a Hooch bucket adapter. Now, as you can see, it's very similar to the Hooch bucket design. This is the first one that's printed successfully. I've only had a couple of tries at it, but I'm really happy with this. This is using a 0.8 millimeter filament extruder. So it's a large filament extruder. It allows me to print a lot faster than the 0.4 one, and I'm currently testing. This is the first 0.8 millimeter extruder for the Hooch bucket that I've used, and it's giving like a really, really solid Hooch bucket. So I'm thinking that the extra filament that it costs to make the prints like this, it's around, I think it's 50 grams more, will give a longer lasting result to the prints. I'm yet to confirm that, and I don't want to just claim things that are just a hunch. So let's peel this off for the first time. This is the first successful print on my new Ender 3 Pro as well. I've obviously got two now so that I can prototype a lot faster. If any of you have any tips on removing extremely high adhesion PETG from a print bed, let me know. I haven't done anything to this print bed. It's literally just raw print bread. All right, here we go. Oh, stop it. So this is exciting. This is the prototype part for, and the first successful print of, the Hooch adapter. Now, the Hooch adapter is an adapter for pots. So you can have any type of pot that has a flat base, place the pot on top of this adapter and glue it down with some kind of plastic adhesive, and you can use any pot on the rain gutter grow system without any support, or
above the ground, elevated with the system. These are just 4-litre round basins that I'm going to be using for strawberries, and in this I'll have 4 strawberry plants, or it depends. I think the literage for media for strawberries is 2 litres, so I might just have 2 strawberry plants and have it wicking up from below. So this adapter can fit onto not only bowl shapes, but you can also have your pots stuck to this adapter as well, and it negates the use of net cups and allows you to have the pot suspended on an NFT, deep flow technique, or rain gutter system. I'm also working on a square version of this design so that you can use windowsill pots and have 2 of these adapters, one on each end of the windowsill pot, so you can have troughs along your rain gutter grow system, NFT, or deep flow technique hydroponic systems. So let me show you the first glimpse of this adapter at work. All right, so a major reason that I wanted to create an adapter for the system is because a lot of print beds just are not large enough to print. This is 30 centimeters across this bowl, and my print beds aren't big enough to print that bowl, and it would be a waste of filament when you can get these for about $2 to $3 a bowl. And that much plastic would cost more than $2 in print filament. To just be able to glue this to the adapter, after you put a hole in the bottom, of course, so that the wicking action can happen, is a major advantage. This was printed with a 0.8 millimeter nozzle, which I'm probably going to switch over to from the 0.4, as it gives you a decent print quality, but the structural integrity of the print is a lot more solid. These prints are a lot stronger than these 0.4 millimeter prints. Even though they take up a tiny bit more filament, I'm happy to pay that extra for the filament because it's a solid print and there's not much loss of detail anyway. I'm going to do a beta recommendation because I've only printed these 2 items, the one that was on the print bed and this item with the 0.8 millimeter nozzle, but probably print in 0.8 millimeters and you'll have a better time than the 0.4 millimeter print. So the way that this system works is that it fits straight over your rain gutter grow system and supports your pots as they hang over the edges. So if they become heavy with fruit, it will support them on the ground. It will stop the pots from moving around or falling off the system if they're suspended in a system like this, NFT, over the top of a rail. I've actually lengthened this net cup in relation to the Hooch bucket as well, and I'm probably going to lengthen the net cup in the Hooch bucket. It now fits just flush of the bottom and allows the wicking action to happen right from the bottom of this pipe. I just had some tweaking to do. As you can see here, it's pretty much flush with the bottom of that pipe. There we go. So you can see I've got it as close to the bottom of that pipe as I can. I could probably come a couple mils closer, but yeah, I want to allow the nutrients to travel up through that center hole. So I'm pretty happy with the depth of that net cup now. And as you can see on the sides, I've left a bit of wiggle room. Now the point of that wiggle room, as with the Hooch buckets, is to allow this hole to be slightly off center. This is just allowing for human error when drilling the holes, so that if it's slightly off center, the adapter will go to the left or the right without you having to fiddle too much with the placement of your holes. All right, this isn't the official video for that adapter. I still want to play around with it. This is the beta. This is literally the first print that I've done of it. I just wanted to take you on the journey of the process that I go through with making them. I'm actually really happy with this prototype. I'll upload the prototype to the Patreon as of the shooting of this video, purely because I'm happy for you guys to print this. It works really well. It took less prototyping than the Hooch bucket, purely because I'd already designed the Hooch bucket and this is based on that design. So yeah, this will be available immediately on my Patreon, and I hope you guys enjoy it. I'll do a full adapter video with time-lapse grow once I get a few adapters set up with pots and bowls and whatnot on top. And I'll probably have a square version of this available for release at that time as well. So I hope you enjoyed the sneak peeks in this update episode of Hoochos, and I'll see you next time. Happy hydroponicking. I gotta go glue some stuff together.